Welcome to the Grid Mod Pod, brought to you by AEIC. In this podcast, you'll hear from the utility industry's top operations leaders on how their companies are working to modernize and improve our ever-evolving power grid. Thanks for joining us.
Welcome to another enlightening episode of the Grid Mod Pod, your trusted source for all things related to grid modernization and the future of energy management. I'm Dr. Elizabeth Cook, the Vice President of Technical Strategy at AEIC, and I'm delighted to have you join us today. Our guest is Rami AlyGad, Manager of the Smart Grid and GIS team at Arizona Public Service. Rami, thank you for being here. So today we are going to dive into grid modernization road mapping, really exploring the process of crafting or preparing for distribution automation strategy, which I'll let you talk about a little bit. Delve into the world of data analytics, my favorite topic, and understanding the pivotal role, which I think a lot of us forget about, is the Geographic Information Systems, GIS, and all of the technologies that are associated with it. So Rami, could you please introduce yourself and share a bit about your background before we dive in?
Yeah, Liz, thanks for having me here today. I'm Rami AlyGad. I'm the manager of Smart Grid and GIS at Arizona Public Service. So really there's two sides of my organization. One side is the GIS services team, which really has two functional areas. It's the GIS data management, kind of day-to-day entry and management of our network model. So at APS, we use the GIS platform as our system of record for our asset locations as well as the network model. And there's also a solution delivery side of GIS, which is taking the system of engagement, like the platform itself, and the system of insights to share that data out to our stakeholders and customers, and then turn that into solutions for analytics, web and mobile apps, different workflows to kind of optimize the way we do our work. The other side of my team is called Advanced Grid Technology, or Smart Grid, which is really focused on the assessment, demonstration, planning and deployment of smart grid technologies across right now our distribution system primarily to enable new capabilities to automate the grid. And so it's a team of engineers that are kind of looking at what are the new capabilities we want to enable and getting the technology set up and deployed in a way that will enable it.
Awesome. And I guess I always like to take an opportunity to ground some of our listeners and just, grid modernization in general is a very large topic. And at the core of every electric utility that is in the midst of this transformation that we're all working through is safety is number one. I mean, the reason why we show up and we are so diligent, and maybe some may say risk averse or slow moving, is ensuring that what we do and the next steps we take to revolutionize, whatever, the grid, safety is at the paramount. And then comes ensuring reliability, and then, of course, affordability. So I just wanted to level set, like having that system of record of all of the assets that we are, as a utility space, regulated to ensure safe, reliable, affordable power is paramount to everything we do. So I think your role is very exciting. And just from my experience of talking to many utilities, embracing that technology team as a core function and capability is paramount, but also a shift from where we were to where we're going. So it's really exciting to hear, your group and where you are within the organizational structure to make the reality of the importance of what you're doing happen. So maybe for our listeners, for your demystifying, right, grid modernization road mapping, what does that mean? Could you walk us through kind of maybe the process or maybe key components that came into play really for your organization, your team, your vision of bringing this technology to the forefront for APS?
Yeah, of course. So I'll say that, grid modernization is a journey, right? And so even organizationally at APS, it's still a journey, right? We're still kind of forming what that team looks like. So I am in the grid modernization organization, and my teams are a part of that. The way that we're kind of forming our definition of what are we trying to accomplish with grid modernization is we actually lean on some of the concepts that EPRI has put together, thinking about a concept called the grid as a platform. So really looking at the grid as having building blocks. So the very bottom, foundational role, right, is the physical infrastructure. meaning getting the technology out there. And it doesn't even have to be smart technology, right? We have poles and wires. That's what makes the system work. And so when you're talking about those types of technology, you need to have good standards, right? So that way that platform is strong. And then as we evolve, thinking about kind of where we are today and where it's going in the industry, thinking about all of the distributed energy resources, electrification that we'll probably talk about more. We also have to have standards on how those things interact with our grid. So it's not just enough to think about the grid itself, but that interconnection process and what are our standards for that. Then on top of the physical infrastructure, we think about the supporting technology. So you can have the communications infrastructure for the smart grid technology. You also have the information systems like GIS, Geographic Information System, or the advanced distribution management system that helps operate the distribution system. And then also planning tools and a variety of other things, right? So what are the technology support?
I just have to commend you for your acronym usage and how you're saying each one. So kudos, keep on going.
I do my best, thanks. So that's the supporting technology, right? And so continuing to build on that, then we get to the capabilities. And I think my team kind of falls between the supporting technology, the capabilities, and then also kind of a side component of all of them, which is innovation. The capabilities, so I think of distribution automation, in my definition, is really a compilation of a variety of capabilities. The big ones that we're focused on are FLISR and VVO. So FLISR is fault location, isolation, and service restoration, or as some might be supply restoration. Really, it's an application to use smart analytics, right? AI in a way to make the grid more reliable with less manual input. And then VVO is volt var optimization, and that's really focused on power quality regulation. And the power quality becomes a bigger focus now and in the future because of the impacts of electrification and DERs and really those changing customer trends and demands, right? It's changing the way that our customers are interacting with the grid. And it's really changing the traditional demand curves that we used to see. So there's all sorts of impacts that we need to be a little bit more agile and dynamic and prepared for in order to keep the grid stable. So that way we can continue to serve our customers to the best.
So there's so much there, and I love it.
Yeah.
And so I like to really, again, pull up, there is, I believe, a general assumption, especially 20 years ago, maybe even 30 years ago, but the evolution of our smart meters or our smart grid, I mean, the word smart was a tool, language, words matter, that we as an industry and then really the external stakeholders grabbed onto and drove, implying lots of things that we can talk about probably and have a great time with. But really what it fundamentally meant to the utility space is that it can communicate more, right? So like remembering where we were and where we've come to is the devices at one time had a very limited amount of communication between each other. And so even like before the smart grid rollout in the early 2000s, the technology, the communication, the capability of all that information interchange wasn't available to us utilities at that time. And the way technology is rapidly moving is really putting us in the crosshairs. And I guess I'll just share, there's like a misunderstanding that the GIS systems and all of the data and kind of those tools that you just spoke of have already been in place and in play for decades. So all of this new technology that wants to connect, like we have a hard time, I think, as a utility speaking the truth of the reality that we're growing with everyone else in regards to embracing data and developing the technology to have that situational awareness. And so you spoke of ADMS or advanced distribution management systems, which is a makeup of many systems. And so I think that's something that we fell short of as an industry, speaking to our regulators, our financial officers, and the public good, the customer service, that you need many parts to make the whole roadmap come to a reality. So you can't just do onesie and twosies. You have to do that full road mapping to really gain access to all of those capabilities you spoke of. So like I see distribution automation, which you mentioned one version is FLISR, is kind of the heart of grid modernization, right? Because it unlocks that full situational awareness to allow, and this is where I'm going to allow you to elaborate on the critical elements and really the considerations that are effective to like launch that strategy. So like, how have you seen your distribution automation? Like, what are the stepping stones to get to where you are today and where you want to go? Because this is a journey.
Yeah, and really, so it goes back to that capability level of the building blocks, right? So we're looking to enable new capabilities, and capabilities can be bucketed with some crossover into two areas. There's the operational capabilities and the planning. And probably up to this point, we've been really focused on operational, but they really need to be, in step with one another, because you have to be able to plan the grid to the way that you expect it to be operated, right? And then vice versa. So when we think about the distribution automation strategy, the journey that I've gone through is focusing on, transparency, rigor, and consistency with our processes, and with our stakeholders. Making sure that we have alignment to what are our stakeholder objectives, what are we trying to accomplish. So that's really foundational in that start of the road mapping, right? Where does the company want to go collective, as a group of leaders that have different functional areas? What do they need out of this? What are their priorities? And then from there, we're able to kind of select certain operational capabilities. So that's like Flisser and VVO, which are collections within themselves. And then the analytical that go along with that, right? So that could be planning, that could be asset management, asset health type of capabilities. Like with VVO, we're talking about power quality, right? How do you know if you're making a difference on power quality if you don't have a way to measure that and do analytics to say, what are my loads? What are my reactive power measures, my power factor, my efficiency, right? And same thing for Flisser and reliability. How do you know if you're making a difference if you're not benchmarking the before and after to say, what is causing these outages and what's making them last so long and impact so many customers, and then how do we fix that? So taking that approach and aligning on the objectives was really key. But I think for the strategy itself, there's a couple different areas that I found to be really important. One is the device readiness. So a lot of times in the kind of smart grid space, it can be almost too exciting at times where you just want to bring everything to the company, right? And it really has to be thoughtful, purposeful, and it has to be thorough in a way that all of the reference documentation, all of the testing and demonstration has been done with enough rigor where your stakeholders can be confident, right? And
Right.
to your point about safety, if you're not thorough, then you're putting your people at risk, right? That technology may not work in the way that you think it's going to. So focusing on like real good device readiness is a key component. And then there's the deployment approach. So how do you choose the areas in which you're going to deploy these? That goes to the analytics, right? You need to understand your metrics and where the problems exist. And if you don't, then you're just kind of deploying in the dark, right? So you need to have some kind of process to choose those regions and prioritize them. And then within those regions, like where do you actually place devices? Because you don't want to just place them everywhere. They have to be strategically placed. Then, of course, in any strategy, you could argue workforce development, right, is really important. So
You're speaking to this. Yeah.
yeah, I mean, you have to be training your people, and you have to be training for every persona that has an impact from these capabilities or technologies, right? So in this instance, if I think about distribution automation and like reclosers and capacitor banks and voltage regulators and all the things that go into this, when we're bringing on those technologies, yeah, for the most part, we might be familiar with the apparatus, like the electrical device itself, but the smart component, those controllers are always advancing. And so being able to train, the operations engineers that are creating settings, the control engineers that are doing those displays, the trouble men that are going to be actually troubleshooting, the crews that are going to be installing, the automation technicians that are going to be commissioning. Like you have to have all sorts of reference documentation. And then the operators, of course, too. So it's
Yep.
like you can't just bring them onto the grid and not have that material ready for them, because then we're not going to use it to the fullest. And then we're putting ourselves in a risky position. So that's a key thing. And that's all outside of the actual automation capabilities, right? Which is something we can dive into.
And I think it's important to spell out, what I heard, through your strategy is to do something such as distribution automation sounds very operational. So that's the operations team. And then what is the operations team within a utility? I mean, that is the engineers, the support roles that are observing and developing how customers are connecting, when they're connecting, and really just fundamental load, not even talk about the dynamic load that we're up against. And then you have the actual planners who are looking at the current existence of the grid, how it's utilized. Their intel and understanding of how the grid is connected from a planning perspective feeds into the settings, the coordination, the device levels of your protection engineers, and then also your subject matter experts of each device that those electrons are moving through. And then you're putting it into a technology platform that may be new to all of those engineers prior, because technology and how to develop and create and understand and make it easily usable so that you can put all this input in. Then you have to deliver it to the operations center who's operating the grid to then send information out to the actual field employees. And so when we have like external stakeholders, observing from the outside looking in, I think just the general understanding of how many different diverse expertise and knowledge base is required for all of those interlinkings to occur. And then on top of that is your financial models, right? Your ability to convey and create a story to say, we need all of these additional people to help support this transformational change, to all of the regulatory and the legality of it is like, how do you speak to the benefit of the customer? Again, knowing, because you get stuck in your little silo, right? So on top of like, what is strategy? I think it's identifying, and as leaders of this industry, is the importance of the people and the processes that will enable and unlock the technologies. And so some have come before us, right? Like those that want to connect solar on the grid 20 years ago. Like that's it. Yes, it's beautiful. But as the utility folk looking out and be like, wait, there's safety concerns. We have to understand what it is, how it's going to interact, how it's going to play. And really, I think prevented everything to move forward was safety. But like we couldn't get that message across. But it's really exciting because I think where you sat, and I kind of want to talk a little bit about the GIS, like kind of did what you did the last couple of questions, is like how like understanding those elemental foundational components of just where the assets are play into that overall vision that you've been sharing prior.
Yeah, and it's really critical to have that unity across teams. So GIS is one of, there's 30 plus teams that work together to actually make all this work. You can kind of divide them into 3 functional areas when you think of like trying to finance it, but that's where the unity is really important in that stakeholder alignment, because any of those areas falling behind, then you're just not going to be successful. And as we're trying to enable new capabilities, it's a lot of coordination to test those and incrementally deliver them. So where GIS comes in is, like I said, it's the system of record for all of our asset locations and the network connectivity. That's what I mean by the model, is how things connect to one another. And then that model is actually promoted into our advanced distribution management system, where all those new capabilities are being built out for the FLISR and VVO and all the increments in between. Yeah, you had a question?
Well, yeah, I guess I just want to share like the stake in the ground. We have had that asset association and connectivity models of our transmission grid for about 4 decades when computers started to evolve. What we haven't had is those that maintain distribution assets. There really was no need because of the phenomena of electricity and the fact that we did not network the distribution until the last 10, 15 years. So network means that instead of A to B, a grid, transmission grid, goes A to B, C, D, E, F, and comes back to each other. So you have to have these very large power flow equations that computers can help facilitate. Now where we're at with the distribution is really a repeat, but at a much grander level, because there's probably 10, if not 1,000 times more distribution assets than transmission assets. So just, what you're talking about, building up that association is newer over the century. Phenomena that the utilities are required to do. So again, for the external stakeholders, like that awareness should be understood and seen as, let's do this together instead of like, what are you doing? Right? Like there's a reality that this must evolve. So, sorry, go ahead.
More complex, for sure. You're right on point, because you think about what FLISR and VVO are built off of. You need all of these feeders or circuits to be tied together. in order to have that shared support depending on the characteristics at that time and the customer profiles. So without those ties, it could be a lot simpler, but we need them for the customer and the grid of the future. But then there's
Right.
also the two directions of flow, right? Where the
And
DER.
even the tied together is newer to some utilities, because the tied together means when customers see outages, it's outside the utility's control most likely. It's a motor vehicle accident, it's a tree falls down, it's weather and blows too hard or ices and assets fall. So when you have the capability, like you just spoke, tie together, it means less customers see that outage because you're able to isolate the incident. Whereas in 10, 20, 30 years ago, we would have spans of wire serving 10,000 customers, but now we have technology that can break that 10,000 into like 1,000 customer pockets, which makes our reliability better and ultimately safer. Anyway, so technology has been proven out, but it takes time to deploy that. Okay, sorry.
Yeah, so back to your GIS question, that's the operational implication, right? Is GIS is creating the model for all these new capabilities to work off of, even the more foundational ones that are pretty much commonplace now, I would say, at utilities, which is like the switching and outage management, right? Like everyone pretty much has a DMS at this point. So getting to that advanced part is enabling these new capabilities.
But we're all maturing at different rates. I'll just say that.
And then on the analytics side, right, GIS plays a role both in the way that it can feed into other systems, like I'll say SIME as an example, but there's other engineering planning tools out there. GIS is that foundational model to feed into there, where we can do our short circuits and load flows and those kind of analyses. But that's outside, right? That's like using GIS as a stepping stone. GIS itself is a robust platform with a system of record, engagement, and insights. So the amount of modeling and analysis that you can do is really wide, and there's a lot of variety. As we move to the future, one part of grid modernization, what we're going through right now, is a transition from what was considered the geometric network model to the utility network model, which is a whole new foundational architecture for utilities and grids, whether it's electric or water or fiber, that's coming out for all of those. So it's a really new paradigm in data architecture and the way we interact with the data, but it enables new capabilities, right, for advanced tracing. And so you can really run through different scenarios of, if I put a bunch of EVs or DERs in this area, what's going to happen to my grid? So you can do all these kind of simulations. Or if I wanted to take an outage in this area, what's that going to look like? So it really just empowers the operators as well as the field to kind of see, and engineers to see ahead of a scenario.
And the importance of seeing ahead of the scenario and having the situational awareness and having the capabilities to respond in almost real time is safety, right? So, and I think everyone may lose sight of it because we don't say it repeatedly, but at the core of, I know the reason, I get up every day and want to educate on the electric power grid, and I think I'm going to speak for you and all of your team, is that effectively the electric power grid is lifeline society, but for us to maintain it, the number one goal is to keep it safe, right? And of course, keep everyone. It so and that's all for the customer, right? So I think it's important when we're telling the stories, because those are wondering, how is the utility going to show up? And it's that idea. We have to share the knowledge that this is all one roadmap. Now you can't just pick and choose. It's all working together. And we're in a space and time where the technology is available. I think our next obstacle, which do not block the path, they are the path, is getting the alignment from all the people to understand that we are effectively moving forward in the right direction if enabled to launch all these technologies you speak of. So I guess I'm going to wrap it up with this question. So you've been on this journey. What is some insight or maybe like some tangible solution that you can share that you're most proud of seeing from like an idea or a thought, and then moving it towards an actual event or solution that you see tremendous value? And I guess I only share that as like, as we are in this journey, there's ways to celebrate the mini wins, and we don't have to boil the ocean, right? Like we can effectively gain successes along this journey that we should, take that moment and take credit for. So, is there anything you can think of? You want to share?
I appreciate that question. I would say, we started the conversation kind of with road mapping. So, I fall back to my original comment of like, we learned in the past of the advanced grid technology team to not just look at every new, cool thing that's out there, right? But to be really targeted. And in order to do that, you have to understand your stakeholder needs. So I would say the stakeholder alignment and the actual road mapping, physically putting what that roadmap looks like so you can create that alignment is really imperative, because without that, everyone is talking about different buzzwords at different times and you don't know what to go after. So we learned that it's not about a big bang approach. Some people may ask, well, when are we going to have Blitzer? Well, what does that mean to you for the whole system, for one feeder? Does it mean that the full service restoration, model-based, rule-based? There's all these things that can get you way overwhelmed. So the idea is to break it up into digestible pieces and say, we're taking an agile, incremental approach. First, we're just going to develop a way to locate that fault. Then we're going to isolate it. And then, you continue to move through that. So I'd say break it up into digestible pieces and paint the picture with your stakeholders and make sure they're aligned to why we're actually doing that, the objectives.
So that does provide great impact. And I think it's important to take those pauses to realize that work that was done and continues to be refreshed is, matter of factly, one of the most achievable signs of making progress. So, I want to thank you, Rami, for sharing your wealth of knowledge and really offering some of your valuable insights. I think it's really important for us as an industry and all stakeholders to understand the intricacies of grid modernization road mapping, the power of distribution automation, and of course, my favorite, data analytics plays into all of it, embracing those technologies in a safe way. So it's been an enlightening conversation, and I thank you again. And to our listeners, we hope you found this episode informative and thought-provoking. So please stay tuned for more engaging discussions to be released weekly. So thank you.
Thank you, Liz.
That's a wrap for this week's episode of the Grid Mod Pod. Thanks for tuning in. We hope today's conversation got you thinking about new and creative ways to improve our power grid. Be sure to subscribe to our YouTube channel to be the first to hear new episodes. This podcast is brought to you by AEIC, the place where operations leaders come together to share knowledge and provide guidance to the electric utility industry. We'll be back with a new episode soon. Until then, keep powering on.